Welcome to this explainer. We are diving right into a monumental shift happening in the tech world right at this very moment. For the last few years, the entire conversation has been totally dominated by massive standalone language models. But as we're going to see today, the true frontier, it's no longer about building one giant single AI model. It is all about architectures of coordinated intelligence. Okay, let's dive into this and explore exactly what that means.
So, is one AI brain enough? It's kind of a provocative question, right? We've basically been treating AI like this all-knowing oracle, expecting a single system to somehow write complex code, analyze the financial markets, pull exact historical records, and orchestrate heavy software, literally all at the same time. But asking this question highlights a massive inherent limitation. We're relying on one isolated AI mind to play the lone genius. And, well, just like in the real human world, the lone genius model has a serious ceiling.
For a while now, traditional AI has been exactly that, a monolithic structure. It's one big brain trying to do absolutely everything, which inherently limits what it can actually execute. But now, we are shifting to a modular reality, what we call multi-agent AI. We're completely moving away from that solitary, overloaded model and moving toward a modular team that actually executes real-world tasks.
Here is our roadmap for today. We'll start by going beyond the single brain. Then we'll meet the AI team, see that team in action, explore exactly why this architecture wins, and finally look at the future of coordinated intelligence. I promise to demystify these complex systems using a really relatable mental model. Basically, think of it like your very own corporate team.
All right, part one, beyond the single brain, the overloaded system. Here is the issue. When you force one single AI to do everything, its context gets incredibly overloaded. It's just trying to hold way too much information in its head at once. And because of this, it suffers from week-long reasoning. It literally loses the plot on complex multi-step problems. Even worse, it doesn't have any real-world execution capabilities. I mean, it can talk, sure, but it can't actually do anything. And since it's trying to guess the right answer from its pre-trained memory, you get a super high risk of hallucinations. The single AI basically just burns out.
Which brings us to part two. Meet the AI team, Autonomous Multi-Agent Systems.
Okay, so autonomous multi-agent systems, or MAS for short, are AI architectures where multiple, completely independent agents collaborate with each other. Every single agent thinks independently, shares structured outputs, and contributes to the overall intelligence. For the rest of this explainer, I really want you to hold on to this mental model. MAS equals an AI team. It's a corporate team where everyone has a highly specific job. Let's actually meet the members of this team.
First up on the roster, we have the planner agent. Think of the planner as your team's manager. When you give the system a really broad task, say, hey, analyze this stock for me, the planner doesn't just jump in and do the math. Nope. Instead, the planner acts as the core strategist. It understands your actual intent and breaks that giant problem down into small, actionable steps. Fetch the data, compute the indicators, make a decision. It maps out the entire strategy.
Next, say hello to the retriever agent. This is the knowledge layer. Think of the retriever as your tireless, late-night researcher. Its only job, literally its only job, is to hunt down exact data. It's out there searching vector databases, combing through server logs, digging into giant document repositories. And why this matters is huge. By having a dedicated researcher, the system ensures its answers are actually grounded, which dramatically cuts down the risk of those AI hallucinations we just talked about.
Then we have the tool agent. Meet your hands-on engineer. This is the execution engine of the whole operation. The tool agent is out there running SQL queries, pinging external APIs, and executing raw Python code. This right here is exactly where the AI transforms from being just a passive thinker into an action-capable doer in the real world.
All right. So once the engineer has pulled all the raw data and run the code, the reasoning agent steps up to the plate. This is the analyst. It's the brain that looks at everything the researcher found, looks at everything the engineer built, and then combines those tool outputs to produce genuine, valuable insights. It forms a highly intelligent conclusion based strictly on the hard facts presented to it. And finally, capping it all off, we have the coordinator. This is the ultimate leader of the team. The coordinator acts as the grand orchestrator. It controls the entire flow of information, it handles the tricky dependencies between all the other agents, and it strictly ensures correctness. Basically, it makes sure all these independent puzzle pieces fit together perfectly before it ever delivers the final polished answer back to you.
Let's move on to part three, the team in action, database debugging.
So imagine you ask your system, hey, why is my database running so slow today? Watch this workflow. Boom. The planner immediately defines the sequence of steps needed to investigate. Then the retriever jumps right in and fetches the most recent server logs. Next, the tool agent takes those logs and writes scripts to analyze I/O wait times and database locks. After that, the reasoning agent looks at the tool's analysis and pinpoints the exact root cause, like say, high I/O wait and some missing indexes. Finally, the coordinator finalizes the report and hands it right to you. It is sequential, step-by-step magic, and it all happens in seconds.
Section 4. Why this architecture wins, and really, the sheer power of mass.
When you divide tasks among true specialists, the advantages are just massive. Reliability shoots way up because each agent is laser-focused, which means way fewer errors. Scalability is off the charts. You can effortlessly add more agents or run parallel execution. Modularity means that if a brand new, better retriever model drops tomorrow, you can literally just swap that specific component out. You get real-world capability because it hooks directly into your APIs and databases, and absolutely crucial here, you get severely reduced hallucinations because everything is anchored in tools and factual retrieval.
If we stack these two approaches up against each other, the contrast is night and day. Traditional AI, it relies on a monolithic structure with very limited execution. It offers at best medium accuracy and low scalability. But compare that directly to multi-agent AI. The structure is completely modular. The execution happens in the real world. The accuracy is incredibly high because of that deep specialization, and the scalability is essentially limitless. Guys, this isn't just a slightly better AI. This is an entirely new stage of AI architecture evolution.
Now let's do a quick reality check here, because it's not all sunshine and rainbows. Managing a whole network of independent agents definitely has its hurdles. First, you've got coordination complexity. Getting all these distinct agents to talk to each other perfectly takes some serious engineering. Second is latency. Because the system is taking multiple steps and passing data back and forth, it can actually be slower than just getting a simple single prompt answer. Third, tool reliability. If an external API randomly goes down, your tool agent fails. And lastly, security risks. With more agents out there actively executing code, the surface area for vulnerabilities, like prompt injection, definitely goes up. These are very real complexities that developers are in the trenches navigating right now. Finally, Part 5, the future of coordinated intelligence. What is next?
So, where is this all heading? Looking at the evolution of mass, in the near term, we're seeing autonomous AI workers. These are agents actually executing code, trading, and researching totally autonomously. Moving into the midterm, we're going to see the enterprise agentic stack. This is where AI agents fully integrate with your company's CRM and ERP systems to automate massive, complex business workflows. And in the long term, we are talking about bio-inspired systems, self-healing architectures, and immune-like fault detection, where the AI ecosystem can detect its own errors and fix itself autonomously. Honestly, very much like a human immune system.
If there is one ultimate takeaway from our source material today, it is this specific idea. Autonomous, multi-agent systems are the foundation of next-generation intelligent AI systems. We are simply no longer dealing with one big overloaded brain. The future is a network of intelligence, passing signals, distributing tasks, and forming brilliant decisions together.
I really want to leave you with this final thought to chew on. A single AI answers questions, but a multi-agent AI, it solves problems. Now that you have this extremely powerful mental model of a dedicated digital corporate team that is just waiting to get to work, I have to ask, what problem are you going to give your AI team? Thank you so much for joining me on this explainer. Keep learning, keep exploring, and we'll catch you next time.